Okay, let's pay attention, please. So we have covered, let's see, 3 different categories of nomenclature. And we're about to get to the last nomenclature naming system we're going to work with here, nomenclature. Okay. We have covered simple organic compounds. Okay. These simple organic compounds that we have learned to name are all hydrocarbons. Okay. We learned to write complete structural formulas. So this is a complete structural formula.
Did you say we needed ionic compounds?
Nope. These are covalent.
Is these the note, like, have we been taking those ionic compounds?
Lately, the past several days, has been all ionic. Okay, we learned to write condensed structural formulas. We learned to write skeletal structural formulas. Nomenclature. Nomenclature. It's a naming system.
Oh, this is what we did the other day with those carbon atoms.
I'm reviewing, yes.
Oh, I know this one.
Okay. Okay. We learned to write molecular formulas, which in this case would be C2H6. And we learned to write empirical formulas, which included things like CH3. This is an empirical formula. Okay. All of these formulas here are for the compound that we learned to name, ethane. Okay. All these are ethane. Just different ways of writing formulas for ethane. Okay. Then we learn to write names for non-organic covalent compounds. Okay. Non-organic covalent compounds are made of all nonmetals. Okay. And we learn to name them using prefixes. Then we learn to name ionic compounds. All right. So when you have an ionic compound, you're either going to have a combination of metal and nonmetal, or that formula is going to have a polyatomic ion in it. That's how you know it's ionic. Okay? If it has a polyatomic ion, it's ionic. If it's a metal combined with a nonmetal, it's ionic. If it's two nonmetals combined together, that's covalent. If that covalent compound doesn't contain carbons that are bonded to each other, it's non-organic covalent. Huh? No, only the organic compounds contain carbon atoms that are bonded to each other. Okay? So compounds that contain carbons that are bonded together are called organic. They are also covalent. Organic compounds are, at least at this level, this point in time, are all going to be covalent compounds. Okay? So we've got two classes of organic. Two classes of covalent. You've got organic and non-organic covalent. Okay? And then we've got the ionic compounds. And the ionic compounds, you don't use prefixes in the name, but you do use Roman numerals for metals that have more than one oxidation number. Yes, where are the tissues? They were on top of the... put them back on the filing cabinet when you finish with it, would you? What? You're getting sick sitting here. Okay? So this is vanadium 5. This is a Roman numeral 5. And this is phosphate. Okay? That says vanadium.
Can I go outside, blow my nose?
So now, we are ready to start naming non-organic acids. Okay? Okay, you got that? Can I change pages now?
Nope.
Non-organic acids. You can recognize the formula for a non-organic acid. Have H on the front of the formula. Okay, so HCl can be hydrochloric acid. H3PO4 can be phosphoric acid. Okay? Non-organic acid. Names include the word acid. In this class, the formulas will always have H in the front. The exception being water. While water can be an acid, we don't think of it at this point in the semester as being an acid. It can be an acid. It can also be a base. What? No, it's just amphoteric. If you get the right, if depending on the conditions, you can make a water behave like acid, or maybe make it behave like a base. Okay. So, what? Include the word acid. Okay. Well, so let's see. Sulfurous acid is H2SO3.